you feel like installing a concrete swimming pool in your backyard and then drowning your math textbook and your math homework in it? That's grand. We can help you avoid getting wet and costly lawyer fees with this video from Fort Bend Tutoring and Mr. Whitt.
Hello, ladies and gentlemen. This is Mr. Whitt with Fort Bend Tutoring, and today's tutorial is going to be about circles and the CenterRadius form. That's right. We're going to be talking about the CenterRadius form of a circle. So first of all, let's look at this form. Okay, so here it is. Here it is right here. It's x minus h squared plus the quantity of y minus k squared, which equals to r squared. What you should know when dealing with the CenterRadius form is that the center itself is going to be hk. That's right. The x value of that center is going to be h, and the y value of the center is the k value. That's right. That's the center. The radius is the variable r. Yeah. And if you look at this diagram right here, if you have a circle, just pretend that's a circle. If you have this circle right here, that the radius is going to be the distance between the center and any point on the circle. And this little line segment right here displays a radius of this circle. All right, notice how it's labeled R right there. That's an R. All right, so let's go ahead and look at some problems. In problem number 1, we have x squared plus y squared equals to 25. What we'll be doing is we'll be identifying the center and the radius of these equations, all right? So in 1a, I have x squared plus y squared equals to 25, and if I'm asked to find the center of this equation, well, that means I need to find the h and the k value. Notice that we don't have any binomials squared in this equation. In other words, you don't see that x minus h squared form or the y minus k squared form. And that's okay. That simply means that the h value is going to be 0 and that the y value is going to be 0. Okay? So all you do is just write 0, 0 here for the center, because that's the center. There you go. Because you don't have any other terms with your x and you don't have any other terms with your y, then the h and k value is going to be 0 here. And that's it. Now, as far as your radius is concerned, remember that the constant over here is the radius squared. So in order to find out what the radius is, you want to take the square root of 25. So my radius for problem 1a is going to be 5. That's it. I'm going to put a red box around this. Okay, because I like putting red boxes around my answer to protect them from you. All right, so there you go. That's going to be 1a. Now for 1b. That's right, looking at 1b now, we have the equation in CenterRadius form, thank you, x squared plus the quantity of y plus 2 squared equals to 36. Remember that if you already have CenterRadius form and you don't have your variable x in a set of parentheses like this y is right here, then your h value is going to be 0. So that means that my center here is going to be 0 for the h value. In order to find that k value, in other words, the y value of my center, all you do is take the opposite of the value inside the parentheses here. So notice that inside of the parentheses with the variable y, you have a positive 2. Remember that according to the CenterRadius form, that value is the opposite of k. Notice that in your CenterRadius form, and I'll put the formula right here, you'll see that it says y minus k squared. Well, that means that the value in here is the opposite of k. It's the negative version of k. So you want to change the sign on that, and that's going to give you negative 2 for your center. So always change the sign of your values in order to obtain your h, the x value for your center, and then also to obtain your k, the y value of your center. Yeah, that's what you want to do. Then let's move on to the radius. Moving on to the radius, because the radius is always going to be the square root of your constant. So the square root of 36 is 6. There you go. You guys are sharp, and I am putting boxes, red boxes, around my answer. Now we're looking at 1c, and in 1c we already are given the CenterRadius form, all right? And in this one we have the quantity of x minus 4 squared plus y squared equals to 9. So when giving the center, I'm going to give them the opposite of this value inside of the parentheses here. I know that in order to find out my h value, I need to find the opposite of negative 4. And the opposite of negative 4 is positive 4. And what would the k value be? You just have a y squared right here. Do you remember what I told you? I hope so. Good, you remembered. Fantastic. You know that the k value has to be 0 because you don't have any other value right there. So it has to be 0. Yeah. Then, as far as your radius is concerned, how do you go about finding the radius here, knowing that the constant is 9? What did you say? Yes, that's correct. You want to take the square root of 9. And what is the square root of 9? It's 3. Are you sure it's 3? Good, because it's 3. So when asked for the center and the radius of this equation, the center of this equation is going to be at 4, 0 with a radius of 3. That's it. That's what they wanted to know. Red boxing it. Moving on to problem 2a. Here we already are given an equation in CenterRadius form. It's the quantity of x minus 1 squared plus the quantity of y plus 3 squared equals 4. So I want to find out what that hk value is, all right? Remember, the h value that you want is going to be the opposite of the value in that first set of parentheses, whereas your k value will be the opposite of the value in the second set of parentheses there, the parentheses that has your variable y. So the opposite of -1 is +1, that's my h value. The opposite of +3 is -3, which is my k value, and this is the center of the circle as far as this formula is concerned. All right, great. Now you want to solve for the radius, that variable r. It's going to always be the square root of your constant, and in this case the constant is 4. So the square root of 4 is, yes, it's 2. It is 2. Absolutely correct. Yeah, let's go ahead and box that up. Boxing up my center, boxing up my radius. Yeah. Now we're looking at problem 2b. 2b. We have the quantity of x minus 3 squared plus the quantity of y minus 2 squared, which equals 16. So when asked for the center, which is going to be once again that hk value, that ordered pair hk is referring to the center of your circle. We need the opposite of -3. You say it's what? Exactly, it's +3. And what is the additive inverse of -2? What's the opposite? Exactly, it's 2. So my center of this circle, based on the equation, the quantity of x minus 3 squared plus the quantity of y minus 2 squared equals 16, is 3, 2. It's 3, 2. What's the radius? The radius of this problem would be what? It's not 16, right? Because that's the radius squared. In order to find out the radius, you need to take the square root of 16. So what's the radius? Exactly. It's 4. It's 4. And you're awesome. That's right, because you had the right answer all along. You were waiting on me to tell you the answer that you already had figured out on your own because you're so smart. Just saying. All right, so I'm going to go ahead and box this with red. Thank you. There you go. And now we're looking at problem 2c. In problem 2c, we have the quantity of x plus 2 squared plus the quantity of y minus 5 squared, which equals 1. And once again, we're looking for the center of the circle. Remember that center can be identified by the ordered pair hk. So inside of the first set of parentheses, we need to find the opposite of +2. And the opposite of +2 is -2. To find the k value, you want the opposite of that -5 value. And the opposite of -5 is going to be 5. Yeah. All right. So that's the center of this circle. -2, 5. Yep. And now you want to find out what the radius is. And so the radius is always the square root of your constant. And the square root of that value over there, that r squared value, is going to be 1. The square root of 1 is 1. There you go. Boxing it. Got my answer here and my answer here. And there you go. That's it. That was problem number 2. Let's move on. All right. In problem number 3, what we'll be doing from this point on is we're going to be writing the center radius form of our equation for a circle given the following information. If they give me a center point of 3, -2 with a radius of 5 and they ask me for the center radius form, I can then write my center radius form like so. It'll be x minus 3 squared plus y plus 2 squared equals 25. And that's it. How do we get this? Using our formula, remember that this is your h value and this is your k value. When using the center radius form, you always find the opposite of your h value. So in this case, my h value is 3, and I needed the opposite of that for my center radius form. So the opposite of positive 3 is negative 3. So that's how we came up with this first set of parentheses here. You're going to definitely square it, and then when moving on to the second set of parentheses, you'll have your variable y and the opposite of your k value. So the opposite of negative 2 is positive 2. So in other words, you want to change the signs of those values when writing your center radius form. Then the value that you have to the right of the equal sign here is always going to be the radius squared. So what do? We squared 5. 5 times 5 gives us 25, and this is your center radius form done and done. Boxing it up, ladies and gentlemen, just like that. In problem 3b, we have the following. All right, we have a radius that equals to 2 and a center that's negative 1, negative 4. I'm going to go ahead and begin by labeling my h and my k value. All right, and writing this answer in center radius form, I'm going to show that I have in my first set of parentheses x plus 1 squared. How did I end up with this value? I needed the opposite of my h value, which is negative 1, and the opposite of negative 1 is positive 1. Then I'll have y plus 4 squared. How did we get that? We took the opposite of negative 4 and we wrote it as y plus 4 inside of our parentheses for our center radius form. And finally, we'll have the radius squared. So remember that radius, this value of 2, is going to be squared. And so your final result here is going to be x plus 1 squared plus y plus 4 squared, which equals to 4. And this is your answer right here for your center radius form. So in 3b, I'm showing that in-between step of that when I actually plug in the values here, I'm using the opposite of my h value, I'm using the opposite of my k value, but when it comes to the radius, this radius value of 2 is being squared. That's how I end up with my result of 4 for my constant here. So my answer is the quantity of x plus 1 squared plus the quantity of y plus 4 squared equals 4. That's the answer. Let's move on to our next problem. All right, with problem number 4, it asks us to find the equation of the circle in center radius form given a center of 2, 0 and going through the point 5, 4. What you want to know is that your h and k values, all right, are going to be labeled first. So you have 2 and 0 as your h and k value. That's the center. And we're keeping in mind that this circle is going to go through the point 5, 4. So how do we utilize this information? Normally, we're given the center and we're given the radius. In this problem, we don't have the radius. So how do we find out what our radius is? Well, what you can do is you can use the distance formula. You want to find out the distance between these 2 points in order to find out what your radius is. So let's go ahead and do that. All right. So we can use the distance formula, which is distance equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. In other words, you take the difference of your x values between the 2 points and you square that, and then you take the difference of your y values of those 2 points and you square that result, and then find the sum of those 2 squares and then take the square root of it. Sounds simple, right? So let's go ahead and begin. I'll have the square root of my x2 value would be 5 in this case, that second point that I have, minus x1, which is 2, and I'll be squaring that result, plus my y2 value, which is 4, minus my y1 value, which is 0, and I'll be squaring that result as well. Okay, so this is what I have thus far. From here, we'll simplify by subtracting within the parentheses, and 5 minus 2 is going to give me 3 squared, plus 4 minus 0 is 4 squared, and that gives me a result of the square root of 9 plus 16. Well, 9 plus 16 is 25, right? And so the square root of 25 is 5, which is the value of my radius, by the way. So my radius is 5. Yeah, the radius is 5. Now, using this information in my initial point, let's go ahead and write our equation. Recall that we have a center of 2, 0, and we have a radius of 5. All right. So here I'm showing that my h value is 2 and that my k value is 0. So plugging this into the center radius form, I'll end up with x minus 2 squared plus y minus 0 squared, which equals 5 squared. From here, I want to simplify this. So I'm going to rewrite it as x minus 2 squared, and y minus 0 is just y, right? So therefore, I don't need to state that it's y minus 0 inside of that second set of parentheses. I'll just write it as y squared, all right? Because that's what it equals to. And then we'll end up with 5 to the second power, which is 25. And this is my equation in center radius form for problem number 4. All right, red boxing it. Done and done with problem number 4. Let's move on to our next one. In problem number 5, we are looking for the center radius form of a circle going through the point 4, 5 with a center at 1, 1. So I'm going to start by labeling the center as HK. Once again, I'll need to find the radius by using this information, but this time I'll be showing you a different way to find out what the radius is. Let's say that I have a point here and we'll label it 1, 1. And I have another point here, we'll label that 4, 5. All right, so we can use a right triangle in order to find the distance of our radius. So if I go ahead and show that I have a right triangle here, all right, like so, I can use the Pythagorean theorem in order to solve this. As far as my legs are concerned, I know the distance from this point to this point. Going from 1 to 4, I have a distance of 3. So this leg is going to have a distance of 3. For our second leg here, we'll have a distance from 1 to 5. All right, so therefore that distance is 4. Your Pythagorean theorem is a squared plus b squared equals to c squared. So using substitution, if I'm to solve for this value of c right here, the hypotenuse, I'm going to go ahead and plug in these values of 3 squared for the first leg plus 4 squared, which equals my c squared. All right, 3 squared is going to give you a value of 9, and 4 squared gives you a value of 16, which equals to c squared. Adding 9 plus 16, we get 25, and that equals to our hypotenuse squared. In order to solve for c, you're going to take the square root of both sides. So the square root of 25 is going to give us a value of 5 for our hypotenuse. This value of the hypotenuse is the value of your radius. So we know that the radius is 5 now. All right, so you can use the distance formula that I showed you in the previous problem, or you can use the Pythagorean theorem to solve for your radius when doing these problems. Now that we have our radius and we know that our center is at 1, 1, the center radius form of our equation is going to be x minus 1 squared plus y minus 1 squared equals to the radius squared, which is going to be 25. All right, and that's your equation in center radius form. Red boxing it, just like that. All right, and that's problem number 5. Moving on to our next problem. In problem number 6, we're asked to find the equation of the circle in center radius form given the endpoints of the diameter, which are -5, 6, and 1, -2. We know the diameter is a chord, a line segment whose endpoints lie on the circle, and this chord goes through the center of our circle. So in order to find out the center of this circle, we're going to start by finding the midpoint of these 2 points. All right, so this is the method that will always work in order to find the center of your circle. All right, so we'll begin by labeling our points x1, y1, x2, y2, just like that. All right, and the formula for the midpoint is going to be the quantity of x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So plugging in our values, you'll end up with the following. You'll have -5 plus 1 divided by 2, comma, 6 plus -2 divided by 2. All right, we'll be simplifying this, and you'll end up with the following. You'll have -4 divided by 2, and 6 plus -2 is the same as 6 minus 2, so that gives me 4 divided by 2. All right, simplifying this even further, knowing that a fraction is a division problem, negative 4 divided by 2 is going to give you negative 2, and then 4 divided by 2 is positive 2. So this is my center. Negative 2 is my h value, and positive 2 is my k value. All right, so now we have our center. The next thing we want to find is the length of the radius. All right, so utilizing the center that we just found and one of the points from the diameter, we're going to find out the distance between these using the distance formula. Remember that the distance formula is the square root of the difference of the x values squared plus the difference of your y values squared. Just like that. So plugging in our values here, I'm going to call the negative 2 to my first point and the 1 negative to my second point. I'll be plugging in these values here. All right. So x2, the x value of my second point, will be 1 minus our first x value, which is negative 2. And that'll be squared plus my second y value, which is negative 2, minus my first y value, which is positive 2. All right. So this is what I have thus far. I'll be simplifying this expression by combining my signs here, and I'll rewrite this as the square root of 1 plus 2 squared plus negative 2 minus 2 squared. From here, we'll be simplifying further. 1 plus 2 is going to give us 3, so that'll be 3 squared plus negative 2 minus 2 is going to give us negative 4 squared. All right. This gives us the square root of 9 plus 16. Well, we've seen this before, right? That gives us the square root of 25, which is 5, which is going to be the distance of your radius. So your radius equals 5, this value right here. All right, let's continue. Using our center and our radius, which equals to 5, we can write our equation of the circle in CenterRadius form now. So it'll be x minus negative 2 squared plus y minus 2 squared, which equals 5 squared. We'll be combining our signs right here. We know that a negative times a negative is a positive, so we'll have x plus 2 squared plus the quantity y minus 2 squared, which equals 25. All right, and this is the equation of the circle in CenterRadius form. Done. Let's go ahead and box this up. Done and done. All right, in problem number 7, we're looking for the same thing. We're looking for the equation of a circle written in CenterRadius form given the endpoints of a diameter. And in this problem, our points are going to be 6, 7, and 2, negative 3. So we'll begin by using the midpoint formula in order to find the center. All right, and then we'll be plugging in our values here. So I'm going to label these points x1, y1, x2, y2, and plug in the values here. So we'll have 6 plus 2 divided by 2, and we'll have our y1 value, which is 7, plus our y2 value, which is negative 3, divided by 2. Simplifying this, you'll have 6 plus 2, which is 8, divided by 2, and 7 plus negative 3 is the same thing as 7 minus 3, which is going to give us 4, divided by 2. That tells me that my center for this circle is going to be 4, 2. This is my h and my k values, all right, the center of the circle. We're going to now use this in order to find out what the radius is, along with one of the points that's given. We'll be using our center for 2 and one of the points from the diameter. And remember, it doesn't matter which point you use from the diameter when finding your radius, all right? Just as long as one of the points you have is the center and the other point is one of the points from the diameter, you can find the length of your radius using the Pythagorean theorem. And I'm going to show you that now. So I'll begin by making a point here and calling it 4, 2. And I'll have another point here and I'll make that 6, 7. And I'll be making a right triangle between those 2 points there. All right, so let's find out what the lengths of our legs are, knowing that we're solving for the hypotenuse here, which is going to be the length of our radius. So the distance going across here horizontally is going to be from 4 to 6. So this leg's length is going to be 2. Then moving from 2 to 7, you'll end up with a difference of 5. So the length of this leg is going to be 5. The next thing you'll want to do is find out what your hypotenuse is using the Pythagorean theorem. So your Pythagorean theorem is a squared plus b squared equals c squared. Go ahead and plug in your leg lengths, so that'll give you 2 squared plus 5 squared, which equals c squared. From here, we'll go ahead and simplify. So we'll have 2 squared, which gives us 4, plus 5 squared, which gives us 25, and that equals c squared. All right. Adding 4 plus 25, we get 29, and that gives us our value of c squared. To find out your value of c, you'll be taking the square root of both sides. So since 29 is not a perfect square and it doesn't have a factor that's a perfect square, you'll end up with the square root of 29 as your value for your radius. All right. Using your center, which is 4, 2, and your radius, which is the square root of 29, we'll have a CenterRadius form that'll be x minus 4 squared plus y minus 2 squared, which equals the square root of 29 squared. All right, so squaring the square root of 29, that's just going to give you a value of 29. So my final answer reads x minus 4 squared plus y minus 2 squared, which equals 29. And this is your answer for problem number 7. Red boxing it. Just like that, ladies and gentlemen. Just like that. That's problem number 7. All right, let's move on to our next problem. All right, for problem number 8, we're given a center at 0, 13, and they also give us the area of the circle, which is 25 pi. So if we're asked to find the center radius form given this information, let's do the following. Let's start by labeling our point HK. I know that the area of a circle is going to be pi r squared. Well, this comes in handy because I know that the given area is 25 pi, and I'm going to set this equal to the formula pi r squared and solve for my radius, okay? So I'll start out by dividing both sides by pi. Oh yes, we get to solve now, right? So the pi's will cancel out, all right, on both sides of the equal sign to leave me 25 equals r squared. What we're looking for now is the principal root of 25. That's right, we'll be taking the square root of it, but we only need the positive version of this, all right? So don't try to get too fancy on me with your plus or minus of the answer. So the square root of 25 is just going to be 5. That's what you need, ladies and gentlemen. The radius of this circle is going to be 5, and we'll use that in our center radius form. So we'll be writing our answer using the given center of 0, 13 as x minus 0 squared plus y minus 13 squared, which equals our radius squared, which is 5. All right, so we have 5 squared here. Simplifying this, you'll write your answer as x squared plus the quantity y minus 13 squared equals 25, and this is going to be your center radius form of the equation. Red boxing it. Just like that, ladies and gentlemen. That's problem number 8. Done and done. Moving on. All right. In problem number 9, we're asked to find the equation of a circle given the center that lies in the first quadrant and tangent to the lines x equals 2, x equals 8, and y equals 3. First, I'll start by drawing our tangent lines. So we have a tangent line that is going to be at x equals 2. So let's go ahead and make a line here at x equals 2. Then I have a line at x equals 8. Then I also have a line at y equals 3. They told us that the center lies in the first quadrant, so our center is going to lie right here because we have the first, second, third, and fourth quadrant of our rectangular coordinate system. So noticing that the center lies between x equals 2 and x equals to 8, what's the difference between 2 and 8? Well, the difference between 2 and 8 is 6, right? Well, if the diameter has to be 6, that tells me that we have a radius of 3. So our center will lie 3 places from our y equals to 3 line, 3 places away from x equals to 2, and 3 places away from y equals 8. So we're going to be counting over from this intersection here, 3 places, and then going up 3 places. So I'm counting over 1, 2, 3, and then up 1, 2, 3 to give me a point right here. And that's going to be our center. That's our center. If I want to complete the graph, I'll have a point here on the circle, That's right. It'll be 3 places from the center in each direction. And I can just go ahead and just plot that just like that. And that's what you're looking at as far as your circle is concerned. When they say that the circle is going to be tangent to the lines x equals 2, x equals 8, and y equals 3, that means that it touches those lines in one spot. So these lines only touch your circle once, all right? So this line x equals to 2 only touches it right here. The line x equals 8 only touches your circle right here. And the line y equals 3 only touches your line right there. That being the case, we now have the information we need for our equation. We know that our center is going to be located right here, which is going to be at 5, 6. So our h value is 5 and our k value is 6. We also know that we have a radius that's 3. Remember, we found out our radius was 3 when we took the difference of 8 and 2 and then divided by 2. All right? So using our found center and radius, we have a CenterRadius form of x minus 5 squared plus y minus 6 squared, which equals 3 squared. Now, simplifying this, your final answer will be x minus 5 squared plus y minus 6 squared, which equals 9. And this is your answer in CenterRadius form. Done and done. Boxing it up, ladies and gentlemen. Boxing it up. That was problem number 9. Moving on. All right, ladies and gentlemen, in problem number 10, this is your last and final problem. We have 3 points on a circle are -4, -3, -2, 1, and 5, -6. And no 2 points given are endpoints of a diameter. All right, so let's see what this looks like on our graph first. All right, we have -4, -3. That's going to be a point right here. And then we have a point at -2, 1, which is going to be right here. And then we also have a point at 5, -6. So we'll be at 1, 2, 3, 4, 5, and then -6. 1, 2, 3, 4, 5, 6 is right here. Okay. So what we know. Oh, you can't see that last point. Here you go. There you go. So what we know is that these points lie on a circle. That's all we know. So I'm imagining that this circle is going to be like this. All right, yeah, I'm imagining that is like that with our given points located here. All right, and what I'm told by the directions is that no 2 points given actually go through the center of the circle. All right, so we need a different way to go about solving this problem. One way of solving this is to set up a system of equations. So remember that we have our equation for the CenterRadius form, which is x minus h squared plus y minus k squared equals to r squared, right? Well, they give us the x and y values of 3 points. So what we'll do is we'll set up this system of equations by replacing every x and y in the equation with the points that are given. So our first equation is going to be -4 minus h squared plus -3 minus k squared equals r squared. And our second equation will have -2 minus h squared plus 1 minus k squared equals r squared. And then finally our third equation will read 5 minus h squared plus -6 minus k squared equals r squared. All right, and it's these 3 equations that are going to help us solve for our CenterRadius form. So what happened was we had our 3 given points, -4, -3, -2, 1, 5, -6, and we used the CenterRadius form to come up with this system of equations. All right, and we're going to start by setting the first 2 equations equal to one another and the second and third equations equal to one another because they all equal to r squared. All right, you'll begin by rewriting this as -4 minus h squared plus -3 minus k squared equals the quantity of -2 minus h squared plus 1 minus k squared. All right, after expanding this, multiplying it out and combining like terms, you'll end up with 16 plus 8h plus h squared plus 9 plus 6k plus k squared equals 4 plus 4h plus h squared plus 1 minus 2k plus k squared. All right? So that's what you get after multiplying all that out. From here, we can actually cancel out some things. We'll be able to cancel out our h squareds as well as our k squareds, because if you were to subtract both sides by h squared, both would cancel out, and if you were to subtract both sides of the equation by k squared, they would both cancel out. Simplifying this further, you'll have 25 plus 8h plus 6k equals 5 plus 4h minus 2k. All right, you'll want to go ahead and set this equal to 0 now. All right, so setting this equal to 0 means that I'll go ahead and subtract 5 to both sides. I'm going to be subtracting 4h to both sides. All right, and I'll also be adding 2k to both sides, like so. All right, so everything on the right side will cancel out. All right, and you'll end up with the following. You'll have 20 plus 4h plus 8k equals 0. And you know what? Let's go ahead and isolate these first two terms. So we'll go ahead and subtract 20 to both sides. All right, just like that. So you'll now have 4h plus 8k equals negative 20. Notice that we can simplify this equation by 4. And I want to simplify because I want smaller numbers if I can get it, right? Okay, who's going to deal with big numbers? So we're going to go ahead and reduce this. You'll end up with h plus 2k equals negative 5. So here we go. We're going to keep up with that equation because we'll be needing that soon. All right, so let's see what happens next. So setting the original second and third equations together, you'll have the following. You'll have negative 2 minus h squared plus 1 minus k squared equals the quantity of 5 minus h squared plus the quantity of negative 6 minus k squared. All right, you'll want to also expand and simplify this equation like we did the last one. So after expanding this and multiplying everything out, you'll have 4 plus 4h plus h squared plus 1 minus 2k plus k squared equals 25 minus 10h plus h squared plus 36 plus 12k plus k squared that I'm going to squeeze in right over there. All right, just like in the last equation, your h squareds will cancel out, all right, as well as your k squareds for that matter. Then continuing to simplify this, you'll have 5 plus 4h minus 2k equals 61 minus 10h plus 12k. We want to go ahead and write it in the same format as the last equation, so we'll be subtracting 5 to both sides, as well as adding 10h to both sides, and subtracting 12k to both sides. Just like that. All right, so what you can expect from this is that your 5s will cancel out on the left side, the 10h's and the k's will cancel out as well, and you'll be bringing down 14h minus 14k, which equals 56. Notice that this equation can be simplified. I think I'm going to go ahead and do that. All right, so I'm going to divide everything by 14. All right, because I like smaller numbers. So we're going to end up reducing this to hk equals 4. All right, now that looks a lot better, right? So hold on to this equation. You'll be needing that. All right, next up. So using our two equations, h plus 2k equals negative 5 and h minus k equals 4, we'll go ahead and use our elimination process to solve this system of equations. So we're going to go ahead and start by multiplying the second equation by 2 because we want one of those variables to be opposites of each other. And we'll start with the k's, all right? So I'm going to rewrite this as h plus 2k equals negative 5, whereas my second equation will now be 2h minus 2k equals 8. All right, we know that our k's will cancel out. I'll end up with 3h equals to positive 3. Divide both sides by 3, and we'll go ahead and simplify this to find out that h equals to positive 1. That's our h value from our equation of the circle. All right, now to find out what our k value is, we can plug in k into one of the previous equations. For instance, I can take the equation h minus k equals to 4 and plug in 1 for h. So plugging in 1 for h, I'll have 1 minus k equals to 4, and then subtracting 1 to both sides, you'll have negative k equals to positive 3, and then dividing both sides by negative 1, we find that our k value is negative 3. We now have our center of the equation, which is going to be 1, negative 3. Yeah, that's our center. Let's go ahead and hold on to that one. That's the center of the equation, 1, negative 3. Now all we need to find is our radius. So let's do just that. Using one of the previous equations in our system, we're going to be plugging in the h and k values from the center that we just found in order to solve for our radius. So substituting those values, we'll have negative 2 minus 1 squared plus 1 minus negative 3 squared equals r squared. We'll then combine our signs here, and it'll be negative 2 minus 1 squared plus 1 plus 3 squared equals r squared. From here, you'll be able to simplify what's inside of your parentheses. That'll be negative 3 squared plus 4 squared, which equals to r squared. Negative 3 squared is 9 plus 16, which equals to r squared. Adding 9 plus 16 gives us 25, which equals to our radius squared. And taking the square root of 25 and finding the principal root, you'll find that your radius is equal to 5. Alright, so what have we learned thus far? We've learned that we have a radius that's 5. We also have a center of 1, negative 3. That's my h and my k value. So now that I have all this information, using the CenterRadius form, we'll have x minus 1 squared plus y minus negative 3 squared, and that equals to 5 squared. Combining our signs here, we'll have x minus 1 squared plus the quantity y plus 3 squared equals 5 squared, which is 25, and this is the CenterRadius form of our final problem. Boxing it up, ladies and gentlemen. Well, that concludes our video on circles, alright, the CenterRadius form. And as always, please rate, comment, and subscribe. This has been Mr. Whitt with Fort Bend Tutoring, FBT. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook. We'd be much obliged.